Frame Advisor provides fast frame analysis for mobile graphics in Android applications. Capture and analyze data from a problem frame to discover what might be slowing down your application or overheating the device. Explore how the frame is constructed and get comprehensive metrics about the objects in the scene to uncover ways to optimize performance. Frame Advisor is free to use as part of the ARM Mobile Studio suite of profiling tools for Android. Download ARM Mobile Studio from the ARM developer website. You'll need to log in with an ARM account to access the downloads. If you don't already have one, you can create one easily for free. Frame Advisor uses Android Debug Bridge to capture data from your device, so you'll need to install this and add it to your path environment variable. Install a debuggable version of your application on the device. You'll need to put your device into developer mode and enable USB debugging. Ensure your device is connected and accessible through ADB. To test the connection, open a command prompt and enter ADB devices. When Frame Advisor opens, you can either start a new trace or open an existing one. Any files you have viewed recently are shown here. Let's start a new trace. Frame Advisor lists the connected devices and the applications installed. Select your device and the application containing the frames that you want to capture. If your application is Vulkan, change the selection in the API settings. Click Next to start the capture session. The application starts automatically on the device. Play the application until you find your problem area. Click Pause or hit the spacebar. You can use the Step button to move forward frame by frame. When I click the Capture button, Frame Advisor is going to capture the next frame. You can capture a frame burst of up to 3 consecutive frames. Today, I'm just going to capture 1 frame. When the capture completes, the frame is shown here. In this release, you can only capture 1 frame burst of up to 3 frames. In future releases, you will be able to continue the application and capture more frames. Click Analyze to see the results. This might take a few minutes, depending on your content and how many frames you captured. Here is Frame Advisor's analysis screen. Captured frames are shown in the frame hierarchy view. You can see all the render passes in the frame and the draw calls within each one. Here, we can see that the frame I captured draws over 657,000 primitives using 426 draw calls within 16 render passes. But before we delve deeper into what was drawn to the screen, let's look at the render graph to evaluate how the frame is constructed. The render graph shows a visualization of the rendering operations that make up the frame. We can see how data flows between render passes and how resources such as textures are produced and consumed. Render passes flow from left to right. This render pass is the final render pass that outputs to the screen. Evaluate the render graph to look for render passes or input or output attachments that aren't used in the final output and therefore could be removed. Here, we can see some output attachments that are not used in a future render pass. It's important to clear or invalidate input and output attachments that are not used to avoid unnecessary memory accesses. You can check whether clears or invalidates are used in the frame hierarchy view. In this example, we can see that some render passes have no consumers at all. They do not contribute to the final rendered output. These render passes could therefore be removed without affecting the output, saving processing power and bandwidth. Let's take a closer look at the final render pass. We can step through the draw calls to see how the scene is built. Draw calls are expensive for the CPU to process, so it's important to reduce the number of them where possible. Look for draw calls that don't render visible changes to the frame buffer. If you don't see any change, draws could be outside of the frustum or behind other objects. Use software culling techniques to eliminate them. Look for instances where many identical objects are being drawn individually, like these pillars. There could be an opportunity to reduce the number of draw calls by batching multiple objects into a single combined mesh, or by using an instance draw call. You might notice that some objects are drawn with a large number of primitives. As you see the object being drawn, decide whether its size and position on screen requires such a high level of detail. Using simpler meshes, particularly when objects are far away from the camera, could significantly increase performance. You can also use the Content Metrics view to find geometry-related problems. This shows a range of useful metrics broken down by frame, render pass, and draw call. For draw calls, add or remove the metrics you want to see here. If we sort the table by the number of primitives, we can find the most complex objects. In this scene, the object with the highest number of primitives is the Sphinx model. 22,000 primitives is a high number for a game object on mobile, so the first step is to see whether this model can be simplified. Fewer primitives reduces GPU processing cost and memory bandwidth. In cases where the model cannot be simplified any further, there are other options to consider. In the Detailed Metrics view, we show a range of metrics about the mesh. We can see here that this mesh has 45,000 indices, and that each index is used by 2 primitives, so there is some index reuse going on here, which is good. However, almost 32,000 of the vertices are duplicates, which means they have identical data to another vertex in the model. It would be worth removing the duplicate vertices, which would give a significant reduction in processing cost and memory bandwidth. If we sort the content metrics data by lowest vertex efficiency, we can find objects that shade more indices than they are using. This can be caused by gaps in the index stream, which cause unused indices to be shaded, or poor reuse locality, which causes indices to be shaded multiple times. The object with the lowest vertex efficiency is the snakehead statue. There are 5 instances of this model in the scene, although only 3 are visible in this frame. For this model, we can see that 5,000 indices are used to create almost 10,000 primitives, which is reasonable. However, we can also see that over 64,000 vertices are being shaded. This is far higher than our index count, which means that some vertices are being shaded multiple times, which is very wasteful. The report also shows that the temporal and spatial locality figures are very high. Temporal locality shows that on average there are over 4,000 indices between reuse of an index value. This is much larger than the post-transform cache on many mainstream ARM GPUs, which can store 1,024 indices. This means that vertices are likely to be evicted from the cache before an index is reused, resulting in reshading. Ideally, index temporal locality should be under 500 to maximize the chance of post-transform cache hits. To fix this, you should reorder the data to move reuses closer together in the index buffer. Spatial locality shows that on average there are around 1,300 indices between neighbouring indices. This shows that data for a single primitive is likely to be far apart in memory, which can reduce the effectiveness of the shader core data caches during vertex shading. Spatial locality should be kept as low as possible, ensuring that vertices within neighbouring primitives are using data that is the same set of cache lines and memory pages. To fix this, you should reorder the data to move neighbours closer together in the source data buffer. To get help on these metrics, you can show their full descriptions using this button. So we've seen how to capture a frame and looked at some of the analysis features available in Frame Advisor, and we've learned a few tips about how to reduce processing power and memory cost. If you have questions about Frame Advisor, visit the ARM Graphics Gaming and VR community forum, where you can see the latest discussions, learn from experienced users, or ask a question. There's a lot more coming over the next few releases of Frame Advisor. As we develop this new tool, we'd love to hear what you think of it. If you have ideas, comments, suggestions or feedback, please get in touch with the ARM Mobile Studio team. For further information and resources for ARM Mobile Studio, visit the ARM developer website.